Yes, ma'am.
Okay, my name is Shalini. I'm a research scholar, and my paper is based on sensing of white blood cell using residual network and a comparison study using various pre-trained network. These are the contents of my presentation. So here, the white blood cells play a significant role in defending our body from diseases. Here, my paper is on blood cancer, which is called leukemia. And this particular blood testing is mainly done using collecting the blood smear and checking under a microscope by the pathologist. Here, both traditional methods and automated techniques are used for blood counting. But in technical methods, better accuracy is achieved only by the skills of the technicians. And if you are using automated techniques in laboratories and hospitals, it is very expensive. So to overcome these difficulties, we need a speedy diagnosis of these particular diseases. And here I have implemented deep learning systems for this speedy diagnosis. This paper, I have done the identification of leukemic cells, whether it is normal. That means whether is it not infected or infected by using a pre-trained network called ResNet 50, and I have achieved an accuracy of 99.61%. And also lastly, I have done a performance analysis using a pre-trained network of Google network and ResNet of different versions of 152, 101 and VGG 16 and 19. And the classification is done through softmax layer. So in current medical field, there are many problems because the diagnosis of each diseases is becoming very tough and very difficult day by day. So for this particular identification of diseases, now in medical field, deep learning networks are getting an important position. And this particular blood cancer, which is called leukemia, is mainly caused due to the abnormal growth of immature leukocytes and which cause a reduced blood count. Our blood, that is the human blood, consists of red blood cells and WBCs, which is called the leukocytes. This red blood cells, the function of the red blood cells is to carry oxygen from lungs to other parts of the body. And this WBCs, which is called the leukocytes, helps to protect the body against sickness. These WBCs are again classified as granulocytes and agranulocytes. These granulocytes consist of basophils, eosinophils, and neutrophils. It has a certain percentage which has to be appeared in our blood. More than that, it is an indication of diseases. Then agranulocytes contains lymphocytes and monocytes. So this particular WBCs are short, and when after short period they get new cells are generated. So when this particular new generation is not performed, there will be an increase in this particular WBCs, and which causes immature cells also increases. So this particular leukemia are categorized into two, that is lymphoid and myeloid. Lymphoid types are called ALL, which is known as acute lymphoblastic leukemia, and CLL, known as chronic lymphoblastic leukemia. And myeloid types are called AML, which is known as acute myeloid leukemia and chronic myeloid leukemia. Each has its infections on adults and children. And mainly this particular cancer, once infected, it is curable by medicines, but 70% it is infected. And there are many treatments, but it is very difficult to cure from this particular disease. Then the data sets which I have used for this for my research paper is from ALL IDB, which consists of 260 blood images, and it contains 130 normal images and 130 cancerous images, and all these are in JPG format of resolution 257 into 257. And a comparison study has been done using various pre-trained network. That means in VGG net, I have used versions of 16 and 19. And VGG 16 consists of a convolution layer, a max pooling layer, fully connected layer. And the VGG 16 consists of total layer of 16 of 5 blocks of layer with max pooling layer. And VGG 19 has 19 layers with the 3 blocks and extra convolution layers, and compared to VGG16, VGG19 utilize more memory. Then Google Net, it contains 22 layers with inception networks and with 1x1, 3x3 and 5x5 convolution filters. Then the RESNet, that is RESNet means residual network, and which has different versions of 101, 152 and 50. And I have used RESNet 50 for my research paper. And the difference between the other deep neural networks and residual network is that it is using residual mapping. So the problem of degradation can be overcome. This is the architecture of the RESNet 50, which is having a convolution, max pooling features, and lastly it is connected with the fully connected layer. This RESNet 50 mainly this RESNet 50 have many activations that take as a Gaussian distribution at the start of the training. It consists of a convolution layer, a stack normalization layer, and a rectified linear unit. So the architecture of RESNet 50 means there are totally 49 layers, and the comprisations of 49 layers are: in the first convolution layer, it consists of 7x7, 64 kernels, and with a stride of 2 in the first convolution layer, and it has a max pooling layer. In the second convolution layer, it has a max pooling layer with a size of 3x3 and a stride of 2. And it comprises 1x1, 64 kernels, and 3x3, 64 kernels, and 1x1, 256 kernels. That is the second convolution layer. Then in the third layer consists of total there are 12 layers. The fourth layer, it consists of 18 layers. Then in the fifth layer, it consists of 9 layers. So summing up all this, it consists of 49 layers, and it is a combination of convolution layers, max pooling layers, and all these 3 layers. And these 3 layers are in each blocks, they are repeated, iterative, they are repeated. And finally, the total, there are 49 layers with an average pool with 1000 nodes in the fully connected layer. And finally, the last layer is the softmax function layer. Here, my proposed methodology is my input image is in the form of RGB format, which is of 225 to 224 format. And my working concept is the flowchart of my research work is the input image is taken from the data set, and a pre-processing work is done. A pre-processing stages, this image can be either downsampled or upsampled. So according to that, the features are extracted. So the feature extraction means there are 2 phases: training phase.
Request you to kindly quickly wind up as you have exceeded 10 minutes.
Okay. So there are training images and testing images. The features are extracted and finally sent to the softmax layer for classification. And finally, the classification is done as normal and cancer. Okay, and then finally, my final detection is a particular input image which is in the RGB format is cancerous or non-cancerous. And lastly, a performance analysis also performed by the for this particular pre-trained network, and I have calculated the accuracy, sensitivity, specificity, PPV and NPV values. Here, most maximum values I have attained to RESNet 50, and in this paper, I have got a better performance of 99.61%. So, what I have to prove is that compared to traditional methods, better accuracy can be achieved with deep learning networks. Thank you. Sir?
Thank you, ma'am. Thank you for your presentation.
Okay.
Good work with respect to the new technologies which you have shared here. So you can share your email address here. People can get in touch with you, connected with you, so that collaborative researches can be done across the globe, ma'am.
Okay, thank you, sir.